Okay, my friends, one more video for our day one of stats. And it's not going to be as long as the last one because honestly, line graphs are really just a subset of bar graphs. I'll show you what I mean. On this first one we're going to look at here, we're going to look at pollen counts again, but this is now pollen counts over about a month. So from March 25th up to April 23rd, this is why I'm miserable right now because they've been high for the past couple weeks. And you can see how it's actually just a bar graph. It just doesn't have the bar, but just the top of the bar. But really, if you think about it, that's all you need. You need to know where the top of the bar is because the top of the bar tells you where the data point is. So what this reads to me is there were a couple miserable days here in late March. There was a couple miserable days here in early April, and then it's pretty much been miserable ever since the first week of April onward. But they are just bar graphs again. They're just minus the bars, just the tops. They're also the line graph parts a little bit loosely interpreted. You notice that some of these things that are connecting points are not lines, but instead kind of curvy. I think that's more artistic. They're trying to smooth out the behavior as it's moving, which may or may not be good, but that's the important thing are the data points that you see, that data point, and so forth. Here's another one. And again, you might be tired of looking at oil data, and it's okay if you are. We're almost done. But I like this one. This is the same. Well, two of these data points are the same as the ones we looked at earlier. In 1973, the U.S. imported 6,000 barrels, or otherwise known as 6 million. I always love the word million. It literally means 1,000. So 6 million barrels were imported in 73 and 9 million barrels were imported in 2019. So what you might actually think is that oil imports grew slowly over that roughly 50-year period. But what's interesting is they didn't. They rocketed up, then crashed, then slowly grew up till about 2005, and they've been kind of declining on average ever since. And what's so interesting about that is just why that's happening. And there's a lot of history in this graph. I'm going to briefly talk about a little tiny bit of it. This was called the oil bust of 1980, and it was a lot of it was due to recessions. There was an oil embargo back here, and oil crises back then. Man, the 70s, you could only get gas on certain days. There was so much of a limitation of oil, which that would also explain this large spike in imports from 6,000 to 9 million. I mean, if you look at this is the amount of oil imported back in 77 equal to the amount we're doing right now. So this kind of economic up and down is exactly what causes, and then we suffer from crises. So this kind of a slow growth makes a little more sense. This drop here, from what I understand, is a little more positive. It's because cars are actually getting more fuel efficient, so there's no need to bring in as much oil. Very interesting, I think. But anyway, it's still a line graph. Time series, mention that real quick. That just means you have time on the horizontal. That's all that means. So we're going by year, 73, 74, 75, and so forth. I thought this would be interesting. A lot of times you can put a second axis on a line graph, actually on any graph you want. So what's interesting about this, as I took the exact same graph you had back here, but I added the U.S. population onto it over that same period of time. And I graphed that in millions. So the population in 1973, if you wanted to get the value of that data point in 73, you would not look over here. You would look at the U.S. population, which means you'd actually have to look over here. So it's just about 200 million people in 1973, and it looks like it grew up to about 320 million in 2019. So just be aware when you're looking at graphs like this, sometimes they have secondary axes, especially if you're looking at things that have disparate measures. For example, this is thousands of barrels and this is millions of people. It would be hard to graph those both on the same set of axes. I tried, and when you do that, one of the things collapses to the bottom because it's so small compared to the other. All right, and I think we have one more, maybe one or two more graphs to look at. This is a fun one, just because we're in Central Oregon. These are the McKenzie Pass opening and closing date history from 1925 up to, it looks like it stops at 2018, I think. I don't think we have 2019 on here, which, and this is interesting, this one got cut off. So it's just interesting because it shows Well, it shows a lot of data, but it also begs a lot of questions. Like, for example, in the closing date history, this means when they close it to traffic, you'll notice that it's trending downward. Now, downward means earlier in the year. So whereas back in the 20s and 30s and 40s, they may have been closing it in January, they are now closing it earlier in the year. And I've had some students look at this and say, oh, that's just proof that this, and they'll make up something. There are probably lots of reasons why it's trending downward. Some people have mentioned weather. They've actually used weather to explain the opening date. So let me just back up here in case you don't know what McKenzie Pass is. It's if you take Highway 242 out of Sisters west, it's a way to access a pass in the mountains. It's extraordinarily rugged. It's extraordinarily gorgeous, for that matter. It cuts right through a lava field, and it gets a ton of snow in the winter, and they close it. They don't bother plowing it because it's too dangerous to drive in the winter. So they just close it and then open it. They close it in the fall or winter and then open it in the spring. And so this is the opening date. You got June, and then you can see it's opening later. It's trending upward. It does go up and down depending on what year you're in, but there is like kind of a slight upward trend overall. It kind of corrects back down to here where they're opening it earlier here. I have no idea what the reasons are. I just think it's an interesting way to look at the data in this form. I like these kinds of time series graphs just because they get a really, really kind of neat look at data as it goes through, you know, some kind of a frame of reference. All right, one last little stop here, and I want to give you a kind of a teaser for the next set of videos. The do's, as I mentioned, these are very, very similar to bar graphs. So the do's are exactly the same. The don'ts are also exactly the same, except for one more thing. And I forgot a bullet here. I feel silly. There should be a bullet right there. And I want to get to that in a second there. I feel better now that there's a bullet. So the don't start at anything other than 0. That's also always important. But don't ignore what's called the margin of error. And I'm going to stop there because we'll get into the margin of error in the next set of videos.